Good morning, everyone. Welcome, all of you. Very, very good morning. So, today's discussion is going to be on the questions of inorganic spectroscopy. So, guys, inorganic spectroscopy, there is nothing much different from what we have already studied. The theory is almost similar, just that it is more numerical based and more, structure determination of inorganic molecules. Just for that, it is used. So the concept of 19F NMR and 31P NMR, this is the same as proton NMR. Yes. So if you can tell me what was the nuclear spin value of a proton, if you can tell me, everyone remembers प्रोटॉन एनएमआर के लिए आई की वैल्यू क्या थी, हाफ थी. फॉर द C13 it was also I value half. The same value is given for 19F. I is equals to half, and for 31P also I is equals to half. इसका मतलब क्या है, that the splitting pattern, all right, the splitting pattern of the 31P NMR as well as the 19F NMR will be the same as a proton NMR only. Just there is going to be a little bit of difference because यहाँ पे metals या फिर heteroatom से connected होगा. ठीक है. So I have taken some questions on 19F NMR, 31P NMR as well as EPR spectroscopy. So let's start our discussion without any further delay. ठीक है. ये आज का हमारा पहला question है guys. Reaction of a bisphosphine with a rhodium complex in a 2:1 molar ratio gives a crystalline solid A. The IR spectrum of a complex A shows a carbonyl band at this much. The 31P NMR spectrum of A consists of two doublets of equal intensity. ठीक है? Where rhodium is 100% abundant and I value is equals to half. The structure of the complex A is. Okay, it's a very, very nice question. So the 19F NMR, 31P NMR, these are used for structure determination of inorganic molecules along with other spectroscopy methods also. ठीक है, जैसे यहाँ पे carbonyl value दिया है. Similarly, EPR can also be used, Mossberg can also be used, so on and so forth. All right, guys. So you have to answer the correct option in the live chat. Yes, good morning. Good morning to all those who are joining up. Yes, Diksha, you're saying A. चलो देखते हैं. तो देखो, this molecule over here, RHCl CO whole twice like this. ठीक है. So this is the molecule, right? अब इसमें हम क्या करेंगे? We are going to first of all see whether the total valence electrons are 18 or not, or it is having any metal bond. तो ये जो rhodium का complex है, इसका structure क्या है? If if we want to understand that, it's okay. Otherwise, only on the data हम final product भी निकाल सकते हैं. ठीक है? तो चलो ये find out करते हैं. Rhodium has 9 electrons, 1 for chlorine and 4 electrons from the carbonyl. So this gives you 14 electrons only. All right, this gives you only 14 electron. तो अब इसका अगर आप dimer भी कर दो, then also you are going to get at least 2 metal bonds like this, so that 2 electrons are transferred from there. तो चलो ठीक है, ये तो dimer है. This is a dimer. All right. and the dimer has to react with a bisphosphine. Okay, so let's say I'm just randomly drawing one of these, ठीक है, क्योंकि ये most probably क्या होगा, एक square planar complex होगा most probably, because rhodium is happy forming a 16 electron species. If roughly it is like this, then what happens? Bisphosphine is reacting in a 2:1 ratio. That is 1:1 metal complex and 2 of the bisphosphine. फिर क्या मिलेगा हमें? In this way, the bisphosphine has connected and you are going to have one Cl and one carbonyl, and let's say this bond has broken over here, तो एक और carbonyl लगा देते हैं. कितने electron species हो गया ये? This is going to be 9 plus 1 plus 4 plus 4 again. So this looks like an 18 electron species, but actually we don't want an 18 electron species again, because rhodium is happy with 16 electrons. तो ये 16 electron species ही रहेगा. And also IR spectrum shows only one carbonyl stretching band at 1985. So we don't need to put it over here. ठीक है, हमें इसकी जरूरत नहीं है. We just have one carbonyl, so it is going to be a 16 electron species because it is confirmed by the IR value, only one carbonyl. Now the 31p NMR spectrum of A consists of two doublets of doublet. अभी ये doublet of doublet कहाँ से आया, right? And that also 31p NMR is showing you. So rhodium has an I value of half. Now what is this rhodium going to do? Rhodium is going to split the signal for phosphorus. Can you tell me what is the topicity of these two phosphorus present? Yes, good morning Manisha, welcome. So what happens is, ये दोनों group अलग है ना, these two are diastereotopic groups. That means they are going to give you two different signals, right? There is no sigma plane. So one signal for this phosphorus, another signal for this phosphorus, right? So we are getting two doublets of doublets. कैसे मिल रहा है देखो. Let's say this is px and let's say this is py. So for the spectrum of px, you are going to first have it split by rhodium. Rhodium की value half है, I is equals to half. So 2ni plus 1 अगर करते हैं, so 2 into 1 into half plus 1 is going to give you a 2. That means you are going to have a doublet. Because of rhodium, rhodium की वजह से एक signal आया doublet. Now this px is again going to be split by the other phosphorus it is connected to. So py की वजह से दोबारा split होगा into a doublet. So what are you getting? You are getting doublet and a doublet, doublet of a doublet, one doublet of a doublet for the px, and do the same thing to py. First it is split by rhodium into a doublet, further 1:1 because of the px. ऐसे करके एक और doublet of doublet बन जाएगा. ठीक है? So all right guys, you are getting two doublets of doublet of equal intensity. So the structure is going to be option number A only. Okay, and finally it has only one carbonyl and it's a monomer, it's not a dimer. That is confirmed by the reaction with the phosphines and splitting. ठीक है, आगे चलते हैं next question पे. The low temperature minus 98 degree centigrade 19F NMR spectrum of SF4 shows doublets of triplets. It is consistent with the point group symmetry. तो यहाँ पे एक ही क्वेश्चन में दो क्वेश्चन है. It is asking you the point group also as well as the 19F NMR also. Yes, all right. So what do you think is the correct answer? But actually, this question is asking you three questions. One is the VSEPR question, another is the 19F NMR question, and another is the point group question. एक ही question में तीन question हो गए. All right, so that's why it is very important. Now, do you know the structure of SF4 from the VSEPR theory? You know that it is a seesaw structure. Yes or no? ये सबको पता है कि नहीं है? It is commonly known as a seesaw structure, right? तो लो टेम्परेचर के ऊपर क्या होगा? फ्लक्शनैलिटी स्टॉप्स. फ्लक्शनैलिटी मतलब इंटर कन्वर्जन ऑफ ऑल द फ्लोरीन्स विल स्टॉप एंड इट इज गोइंग टू बी अ रिजिड स्ट्रक्चर नाउ. तो अगर ये रिजिड हो गया, then there are two axial and two equatorial fluorines. How are they going to split? Sulfur is inactive because it has both the even atomic mass and atomic number, इसलिए ये inactive हो गया है. So the axial fluorines, there are two axial fluorines, they are going to be split into a triplet, okay, like this, by two equatorial fluorines. So ये एक ट्रिपलेट आ गया यहाँ पे 1:2:1 इंटेंसिटी का, because 2Ni plus 1, 2 into 2 into half plus 1 is going to give you 3. तो ये ट्रिपलेट में स्प्लिट कर देगा Fa को. Similarly, the Fe has, there are two equatorial fluorines and there are also two axial fluorines. So दो axial fluorine इसको फिर से किसमें split कर देंगे? Into a triplet. So what are you ultimately having? You are having doublet of this triplet of equal intensity. So you are going to get this doublet of triplet consistent with this structure. And what is the point group of this structure? It is very simple. यहाँ से एक C2 axis जा रही है, ठीक है, और फिर एक सिग्मा प्लेन ऐसे होगा, एक सिग्मा प्लेन ऐसे होगा. It is going to be a C2V point group. All right. It is C2V, isn't it? Not C3V, not C4V, because इसके लिए 90 डिग्री चाहिए, इसके लिए 120 डिग्री रोटेशन चाहिए, टेट्राहेड्रल है नहीं है. So it is going to be C2V only. Very simple. Now look at this question. It's an awesome question that we have from the 30th November 2020 paper. ये देखो, ये बहुत easy है, it's not difficult. Consider the proton NMR decoupled from the proton as well as platinum. ठीक है? Spectra for the isomers of A and B separately. The number of 31p NMR signal for different isomer of the complexes are given in the table below. The correct answer is the set. ये इतना easy है कि आप सोच नहीं सकते. But since there is a lot of data given, that's why you might be scared. So guys, exam बहुत पास है. That's why we are practicing some typical questions. And if you see some really big question in the exam, don't get scared of it. पहले उसको पढ़ना अच्छे से, and then try it. And अगर नहीं आ रहा है तो कोई बात नहीं, but just don't get scared of the question by looking at the size of it. कई बार ऐसा होता है, खुदा पहाड़ निकली चुईया. Right. So let's say कौन से complexes की बात कर रहा है? PME3 whole 2. So what is this complex? What could be the geometry of this complex? It could be, let's say, tetrahedral or square planar. Coordination number is 4. But platinum will prefer square planar. चलो बी भी देख लेते हैं. Iridium IRCl3 PME3 whole 3. ठीक है. This is an octahedral complex and it can form a facial and the meridional isomer. ठीक है, दो isomer बना सकता है, facial and meridional, and in the square planar you can get a cis or a trans. Okay, very well. Two isomers are possible. Now it's not mentioned complex A, complex B. Isomer 1, isomer 2 बताया है. Facial, meridional not mentioned. ठीक है. चलो A में चलते हैं. First of all, let's talk about A. So there is platinum, then there is a Br, this is a cis complex. Now the question is saying decoupled from the proton, matlab these methyls are not going to split this, and also decoupled from the platinum. The platinum is also not interfering. Only you are getting the you are only getting the number of signals, no, not even splitting. तो इसमें कितने signals आ सकते हैं guys? You tell me. It is a cis complex. How many signals could be possible? They're not even asking you splitting, they're just asking you the number of signals. So both of these are different because there is no sigma plane or a C2 axis. That's why we can imagine two signals. This is separate, this is separate. लेकिन यहाँ पे जो trans है, cis में you're getting two, trans में you are having a sigma plane of symmetry passing through the bromine platinum chlorine bond, right? And these two will be the same. You are getting only one signal. ठीक है, ये हो गया A के आइसोमर. B में चलते हैं. Iridium we will take the facial complex first, PME3 and PME3 like this. So since you already know it is the facial isomer, तो guys facial की क्या possibility होती है? That you form a face on one of the sides and another face on the other side. तो इसमें क्या है? A C3 axis. So a C3 axis is going to make all of the phosphines same. सारे phosphines same हो जाएंगे. Isn't it? Rotate by 120 degree. This comes over here. This comes over here. So only one signal for the facial isomer. ठीक है? And if I draw the meridional isomer, you will see that there are two signals. Because meridional isomer में भी एक point group होता है, एक sigma plane होता है. ठीक है, चलो. So where is the sigma plane over here? If you can imagine a sigma plane that contains, ये देखो, there is going to be a sigma plane that runs parallel to the PME3 and the Cl bond. A sigma plane that contains all of these group. ये वाला, ये और ये. This is the sigma plane cutting the molecule like this. So both of these phosphines have become same and only one phosphine is different. तो कितने total phosphine signal आएंगे? दो. Two again. Okay. So 1 2 1 2 you are getting complex A. One isomer 1, two isomer also 1. No. Complex A के दो isomer है 1 और 2. A के दो isomer है 1 और 2. So 1 or 2 signals you are getting. Complex B में भी दो isomer है 1 and 2. So this 2 is the correct answer. That's it. That is what I told you. Complex A में दो isomer है 2 and 2. बिल्कुल wrong. Not 2 and 2. And complex B में 2 and 2 are again not possible. Both the isomers, one is showing one signal, the other one is showing two signal. Here also same thing, one signal, two signal for B. Okay. So this is so easy. Answer is option number 2. Let's move onwards. और बहुत मजेदार क्वेश्चन था ये. Let's move onwards to the next one. Number of lines in the 19F NMR spectrum of this complex at minus 120 degrees centigrade, assuming it is a mixture of static conformations given below are. Okay. Yes, very good, Diksha. Only Diksha is answering, guys. What about everyone else? सभी को आंसर करना है तभी मजा आएगा ना. So yes, what were we talking about? Number of lines in the 19F NMR spectrum we have to find out at minus 120 degrees centigrade of this molecule, assuming it is a mixture of only 3 conformations. मतलब कि देखो minus 120 centigrade पे क्या होता है, there is not enough energy to constantly rotate the carbon 1 and carbon 2. इसीलिए the molecule is going to be fixed. In some conformation it will be fixed, कोई तो conformation होगा, तो ये तीनों conformation mentioned है only in these conformations. Now the questioner is asking you, अब इन तीनों को मिला के कितनी lines मिलेगी of 19F NMR? Got it? Let's check. So first of all, in this first example, the first conformation over here, we see कि fluorine are opposite. I can very clearly see a sigma plane of symmetry present over here. एक plane of symmetry present है, which means let's say I'm mentioning this as FA. Then this is also FA. फिर हम ये दोनों में जाते हैं, इसमें हम चेक करते हैं सिग्मा प्लेन है नहीं है. C2 axis, not at all. What do we have? We have both of these mirror images to each other. ये और ये दोनों एक दूसरे के mirror images हैं. What does that mean? That means one fluorine, another fluorine. This is fluorine B, this is fluorine C. Then this is going to be fluorine C and this is going to be fluorine B because these are mirror images to each other. Okay? तो अब देखो ये तो same था. Only one signal for FA, but the FB and FC are going to split each other, right? FB is going to be split by the FC into a doublet and FC is going to be split by FB into a doublet again, और ये तो singlet ही होगा. तो total कितने lines आएंगे? How many number of line? देखो, they are not asking you signal, they are asking you lines. So one line for FA singlet, doublet for FB, another doublet for FC. कितने lines आए total? Total number of lines 5. So D is the correct answer. Got it? चलो आगे. Next question. 31 PNMR, which is proton decoupled spectrum of this molecule, is expected to show how many signals and what kind of signals? अब देखो guys, in these kind of questions you have to have some preliminary idea about the structure of the molecule. 2266 N4P4Cl4 NMe2 whole 4. See, it is mentioned in this question, in this nomenclature 2266. इसका मतलब क्या है? could be a structure like this, or it could be something like this. Okay, ऐसा भी हो सकता है, ऐसा भी हो सकता है, ठीक है. But we are just going to write it in a simple manner because we don't care so much about the geometry. We only care about the different number of atoms present. तो सिर्फ हम किस पे फोकस करेंगे? 4 nitrogen and 4 phosphorus are present. 2266. If we if let's say we consider this, अगर हम ये वाला molecule consider करते हैं, तो what is going to be the spectrum for the 31p NMR, number of peaks? Yes everyone, and it is also mentioned कि आपको प्रोटॉन की वैल्यू नहीं लेनी है, not proton coupled. Yes, think about it and tell me. Yes guys. A, चलो check करते हैं. So, is there a C2 axis within the molecule? Can I rotate the whole molecule like this? Which makes this phosphorus and this phosphorus same, and these two are also going to be the same. ठीक है? तो ये दोनों same हो जाएंगे, तो actual में क्या signal आएगा? The first signal, the type of signal we are going to get only two. दो signal आएंगे. Why? One phosphorus, let's say this is P1 P1 and then this is P2 P2. ऑल राइट, या फिर पी ए पी बी कर देते हैं. 1 2 का तो फिर फॉर्मूला में हो जाता है कंफ्यूजन, ऐसे करके. सो टू सिग्नल्स यू आर गोइंग टू गेट. नाउ ईच फॉस्फोरस इज सराउंडेड बाय टू ऑफ द डिफरेंट टाइप ऑफ फॉस्फोरस. ये वाला जो फॉस्फोरस है, थ्रू अ नाइट्रोजन इट इज कनेक्टेड टू अनदर फॉस्फोरस विच इज ऑफ द टाइप बी. ऑल राइट, सो दिस इज गोइंग टू बी स्प्लिट इनटू व्हाट? अ ट्रिपलेट, नथिंग एल्स. ठीक है. और वैसे ही दिस पी बी इज सराउंडेड बाई दो साइड पे पी ए. सो दिस इज ऑल्सो गोइंग टू बी split into a triplet. What are we actually getting? Two triplets. We are getting two triplets. ठीक है. So A is the correct answer for this one. ऐसे बहुत सारे अच्छे अच्छे questions हैं CSI net में. If you haven't practiced, please do. Next question. If chlorine trifluoride were to be stereochemically rigid in the its 19F NMR spectrum for I value is equals to 19F is equals to 1 by 2 would be, assuming that the Cl is not NMR active. All right, guys. Again, stereochemically rigid. Chalo, let's try this out. So ClF3 based on VACPR, what is the structure? आपको पता है ClF3 is going to be T-shaped. All right. Now this is stereochemically rigid at low temperature. 19F NMR is going to be, there are two axial and one equatorial fluorine. So the axial fluorine is going to be split into only a doublet by the equatorial fluorine क्योंकि वो एक ही है. ठीक है, ये doublet हो गया. Then the equatorial fluorine is going to be split into a triplet because of the axial fluorine क्योंकि axial fluorine तो तीन है, right? So what are you getting? Getting a doublet and a triplet. A doublet and a triplet. That's it. Only you had to find this little thing. हाँ बिल्कुल टी शेप है बिल्कुल. तो ये इतना आसान सी चीज आपको निकालनी थी. आई वैल्यू फॉर आई फ्लोरीन वी ऑलरेडी नो. ऑल राइट गाइज, अब आगे हम चलते हैं. वी हैव ईपीआर क्वेश्चंस टू सॉल्व नाउ because I think we have done like good enough questions on 19 FNMR and 31 PNMR. बाकी आप PYQ में से प्रैक्टिस करना, बहुत सारे क्वेश्चन हैं. एंड ऑल्सो गाइज many important notifications for all of you. पहली बात तो आपका एडमिट कार्ड आ चुका है. For those who have not yet downloaded the admit card, please do. And for those who have downloaded, very good guys. ठीक है, तो नेक्स्ट जो मैं आपको बताने वाली हूँ, कैटलिस्ट डिटेल बैच फॉर योर जून 2024 प्रेपरेशन. सॉरी जून 2020, या जून 2024 प्रेपरेशन. तो अभी जो एग्जाम आने वाला है, दिस इज गोइंग टू बी बेसिकली, वो जून में हो या जुलाई में हो या कभी भी हो, you are going to have the validity of this batch till that examination, and you are going to get recorded plus live session of organic and inorganic chemistry along with topic wise assignment and complete test series और live doubt clearing and practice session के साथ में at 5999, and you are also having the test series included in this. Also टारगेट बैच उन लोगों के लिए है जो गेट के लिए प्रिपेयर करना चाहते हैं, गेट 2025 के लिए. Okay, so this course has more than 1 year validity because आपका GATE 2024 exam is going to be in uh, February 2024, but this exam will be there in the February 2025. So I'm launching this course right now. तो आपके पास इतना ज़्यादा time है that you will be able to learn all the important concepts and revise nicely. मतलब आपके पास learning का, रिवीजन का, प्रैक्टिस का, सबका टाइम है इस कोर्स के अंदर. ठीक है, एंड एज वेल एज डाउट क्लियरिंग सेशन का भी. सो दैट इज व्हाई दिस 1 year, more than 1 year course is 8999 for all of you to join up. एंड लास्टली निम्बस बैच, जो ये एक छोटा सा बैच है, लास्ट मिनट प्रैक्टिस फॉर द गेट 2024 एग्जामिनेशन जो अभी आने वाला है फेब में. लास्ट 1 month का बैच है ये. प्रैक्टिस सेशंस ऑफ CSI नेट क्वेश्चन जो एकदम लेटेस्ट वाले अभी अभी सेशन हुए हैं, ऑल दो सेशंस विल बी प्रेजेंट इन द रिकॉर्डेड फॉर्म फॉर CSI नेट क्वेश्चन. ऑल्सो लाइव प्रैक्टिस सेशन ऑफ द गेट क्वेश्चन. गेट के लिए जो भी क्वेश्चन है उसकी लाइव प्रैक्टिस होगी. And this course is going to cost 499. Okay, so these are the 3 courses I have launched. मैंने कल रात को इसके लिए एक वीडियो भी प्रोवाइड किया था सभी को. And I want all of you to, जिनको भी ज्वाइन करना था डिटेल बैच, to join as soon as possible because the content is already delivered. You just have to start studying. Okay, don't waste any time कि एग्जाम के बाद करेंगे, अभी भी आप पढ़ सकते हो. ठीक है, चलो let's move onwards. Next question. In the EPR spectrum of methyl radical, the number of lines and their relative intensity respectively are. Yes, Supriya, very good. But what about everyone else, guys? In the EPR spectrum of methyl radical, that is just a CH3 radical. All right, like this. The number of lines and the relative intensity. तो एक बात बताओ, ये इलेक्ट्रॉन का सिग्नल है ना? Who is going to split this signal? इलेक्ट्रॉन का सिग्नल कौन स्प्लिट करता है? Adjacent protons. So there are 3 protons present over here, 2ni plus 1 formula से 2 into 3 into half plus 1. 3 plus 1 is 4. So the number of lines is going to be 4. You're going to split this into a quartet and the relative intensities are going to be like this. Okay? 1 is to 3 is to 3 is to 1. So D is the correct answer. बहुत easy है ये. Not C. No, 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 no. 1 2 2 1 थोड़ी ना होता है quartet. 1 2 1 is just a triplet. Quartet is 1 3 3 1. ठीक है? Next. In the EPR spectrum of tetragonal copper 2 plus complex, when G parallel is greater than G perpendicular is greater than G equatorial, the unpaired electron resides in the orbital. Yes, Rama, Maruti, everyone, welcome. So most of the questions we have done. ये last के 2-3 session 2-3 questions बच रहे हैं जो हम अभी कर रहे हैं. We have mostly done questions of 19 FNMR and 31 PNMR. Chalo, let's answer this question now. EPR spectrum of tetragonal copper 2 plus complex. अब ये tetragonal copper 2 plus तो हमें पता ही है, it is going to show you Janteler distortion. Where G parallel का क्या मतलब है? And what is G perpendicular and what is GE? GE is our standard. ये है electron density of an electron. Now this is based on the electron की G किस direction में ज़्यादा है? Which direction has a higher G value? So this direction is the Z direction that we have taken. All right. In question, it's not mentioned which is the internuclear axis. So let's compare it is Z only. या फिर ऐसे ले लेते हैं. This is the Z axis. All right. This is the X axis and this is our Y axis. ठीक है. So what is the G parallel? G parallel is dz square. Okay, dz square has the maximum number of electrons. Then comes G perpendicular, which is dx square minus y square. All right. And then comes the GE of the electron. तो अगर Janteler distortion है, if there is a Janteler distortion, then dz square is going to be having 2 electrons और एक unpaired electron रहेगा dx square minus y square में, because it is going to be like this, more stable like this. ठीक है, ये ऐसे के ऐसा ही रहने देती हूँ मैं. I'm not showing the distortion over here, only showing the distortion over here, because here you are having one electron, the unpaired electron resides in this orbital. Same question आपसे ऐसे भी पूछ सकते थे कि ये कौन सा Janteler distortion है? What kind of a Janteler distortion is this? Is it elongation or is it compression? Is it elongation or compression? जहाँ पे dz square ज़्यादा stable होता है. dz square is more stable means the ligands are being removed from the z axis. इसका मतलब क्या हो गया है ये? It's elongation. All right, and that's why the dz square relaxes. और यहाँ पे क्या होगा? The dxz and the dyz, they are also going to relax. ठीक है, आगे चलते हैं. So answer is option number B. The total number of fine and hyperfine EPR line expected for octahedral high spin manganese 2 plus complexes are respectively. What are the fine and the hyperfine lines in the EPR spectrum? चलो देखते हैं. So we are only considering for manganese. Manganese 2 plus is a D5 system. All right, high spin complex of manganese 2 plus is a D5. कितने unpaired electrons हैं यहाँ पे? 5 unpaired electrons. Okay, so 5 unpaired electrons का अगर हम hyper fine line निकालें 2ni plus 1 से 2 into should we write 5? No, we'll write 5 by 2 and 1. Yes, 1 manganese and 5 by 2 is the I value. तो ये हो गया 6. What is 6? Number of hyperfine lines. ठीक है, लेकिन ये जो number of hyperfine lines है, this we have considered only for one electron. If you multiply this by 5, you will get for all the 5 electrons. So 5 into 6 is equals to 30. ठीक है, तो हमारा आंसर होगा ऑप्शन नंबर सी. यू आर हैविंग 5 fine lines and 30 hyperfine lines for each electron. There will be 6 lines like this. Okay, तो ये करेक्ट आंसर है. आगे चलते हैं guys. Very interesting question. A complex A which is given over here, deuteration of NH proton does not alter the EPR spectrum. The number of hyperfine lines expected in the EPR spectrum consist of A is, ये वाला हमारा मॉलिक्यूल है A. इसमें number of hyperfine lines निकालनी है when the I value for the copper is given to be 3 by 2. The first condition is very important. It is a self-explanatory condition कि इसको कोई फर्क नहीं पड़ रहा. When the NH is removed and you are getting a ND, there is no difference. Yes. इसको कोई फर्क नहीं पड़ रहा. If I'm just removing this hydrogen and if I'm putting a deuterium over here, it is not going to change anything. That means we are not considering the hydrogens into the splitting of signals. ये जो 2ni plus 1 है, ये कॉपर के इलेक्ट्रॉन के लिए लगाएंगे. So 2 into n and 3 by 2. Hmm. Yes, it is the Drago's rule. So we are only counting for copper. एंड या इससे हाँ चलो ठीक है एक ही साथ में मल्टीप्लाई करते हैं rather than doing the multiply in the end. So we are only finding out 2ni plus 1 for the copper multiplied by इलेक्ट्रॉन कहाँ है इलेक्ट्रॉन तो कॉपर के ऊपर ही है. It is a 3d9 system. 3d9 is let's say um, dx square minus y square में एक अनपेड इलेक्ट्रॉन है मान लो कोई बात नहीं. तो that one unpaired electron is going to be delocalized throughout the system. That's why it is going to be split by nitrogen and by copper, not by the oxygen, क्योंकि oxygen में क्या होता है सब even होता है, that's why, and not by these hydrogens. Why? क्योंकि ये जो hydrogen है these are connected to an active nitrogen. So when the nitrogens are connected to an active group, nitrogen is active, इसीलिए ये हाइड्रोजन स्प्लिट नहीं करेंगे, they will not split. But if the same hydrogen is connected to oxygen which is inactive, then the hydrogen is going to become active, right? ये क्या है भाई, ये है Drago's rule. Okay, so here we have seen 2ni plus 1 for copper, copper के लिए ले लिया, 2ni plus 1 for nitrogen, not for oxygen, not for this hydrogen. So you can just simply calculate 2 into 1 into I value है 3 by 2 multiplied by 2 into how many nitrogens are there, 2 into I value है नाइट्रोजन की, it is not mentioned, ठीक है. So ये 14 नाइट्रोजन है, that's going to be 1 I guess, plus 1. All right, A is the correct answer, 20. तो बहुत easy question था, Drago's rule लगाया हमने. Right now these are all the questions that we have done, all for 19F NMR, 31P NMR, EPR spectroscopy. आज हमने इतने क्वेश्चन प्रैक्टिस किए हैं. Now what happens is, again I am requesting all of you to join up this CSI net batch course as soon as possible, because the content is already there, and I'm not like throwing away all the content at you, I'm adding it step by step so that you can first focus on one unit. तो अभी एक यूनिट पे फोकस करना है, असाइनमेंट करनी है, then the live classes are going to start from let's say 1st of January. Okay, so the live class is going to start a little late so that you have enough time. Live classes में क्या करेंगे, doubt clearing as well as practice sessions. So तब तक आपका थोड़ा सा concept पढ़ना हो जाएगा. The same I am going to do with this target gate batch. Okay, first you study, then we practice. ठीक है? So yes guys, you just have to download my app, and on the app you are going to get these classes. All right, I will see you all soon in another such session. Bye everyone, and also download your admit cards if you haven't already. Admit card भी आ चुके हैं, ठीक है? Yes, I will see you all in the next